Okay, here we are, question number 18. This one is dealing with a expected value and in a very real setting. This is what let's call it an actuary, works for usually insurance companies. They are the ones who are responsible for pricing the premium on an insurance policy to make sure that there's the money to cover the losses plus make a profit for the company. So this question is a little bit backwards, but we'll go ahead and go through it either way. So we've got an insurance company, Vicana, I guess. They're a major insurance company. And let's see, you can read through it. They've got a 5-year life insurance policy that is built to cover people from 65 years old. Or insurance life policies to 65 years old. If the holder of one of these policies dies before the age of 70, the company must pay out an amount of $24,100 to the beneficiary of the policy. Executives are considering offering these policies for $916. And again, they're the wrong people to be pricing a product. You need your actuaries to do this. And you'll see the executives didn't know what they're doing. Suppose that for each holder of a policy, there is a 4% chance that they will die before the age of 70. And again, the actuaries have these tables of life expectancy. And then there's a 96% chance that they will live to the age of 70. And if they hopefully live longer, but once they're past 70, there's nothing to pay out. So now what we want to do is we want to find whether they will make money with this policy, whether they are going to lose money with this policy, or whether they're going to break even. So we want to know if they're going to win or lose or make money. Lose, yeah. We want to know the expected value. Is the expected value positive or negative? Well, expected value, what we're going to do is we're going to take the probability times the payout. And the probability of 96 times its payout. So the first thing is the 4% chance that one of the policyholders dies, which is what life insurance is about. There's going to be a payout of $24,100. So let's write that down. But this person paid the premium. So we'll go with the net that they actually will end up receiving. They paid the $916, so they get a little bit less if you think of that they've already paid it. Now we got to think of this payout from the perspective of the insurance company. Is this a positive or a negative? Well, it's money that has to come out of their pockets, so this is a loss for the insurance company. It's a negative. Here we go. What's the probability of that happening? 4%. Right here, 4% chance that they're going to die. So that's 0.04. 4% as a decimal. The other thing that could happen is the person doesn't die. And in that case, there's a positive gain to the insurance company of $916. So that's the value times the probability, which is 96%. 96% as a decimal divided by 100, you get 0.96 or 0.96. We plug all of this into a calculator and we'll get the expected value. There we are. So let's see if we can do this. So it's going to be a negative. So I have to change back to the cursor. Negative, parentheses, 24,100 minus 916 we just do a times 0.04, and then we're going to add to that 916 times 0.96. Calculator will do the order of operations, carry everything out correctly, let equals, and we come up with negative 48. I did this last time. I thought I got positive 48. No, that's right. I did get negative 48. But it's now there's something to be careful about here. It means the company's going to lose money. Every policy they sell is what's happening. On average, they're going to lose $48. See, that's why you don't get the executives involved in these kind of decisions. You get the professionals. They should have a higher price on that policy or a lower death benefit. They just didn't price it right. So they're going to lose money. Let's go with here. They're going to lose money. So we choose this, they expect to lose money. And what they're going to lose is $48. Now, we had one like this earlier. I think it was maybe number 7 or something. But they weren't losing money. This is the one I wanted you to note. So the word lose is a negative value. So we don't put in negative 48 here or we'll get marked wrong. We put in the 48, the lose, since it's expected to lose that money, that's our negative. We want the value, the quantity, the amount of the loss is $48. So even though we had a negative 48, I mean, this one doesn't have an answer space up here, but if it did, you know, how much will they, you know, will they make or lose money? How much? This is like up here, we'd have a negative 48. But down in this one, because it's in this sentence, they're going to lose $48. It's already got the negative built in. Hopefully it makes sense. Expected value is the value of the win or loss times its percentage times its probability, plus the value of the second thing that could happen times its probability. And oftentimes in problems, we have more than 2 possibilities, so there could be a third, a fourth, a fifth thing that happens. Put them all together, and that's how you get your expected value. Okay, we're getting close, so we're going to stop this one and move on to 19.